Hey guys, we need to do an example of a question where you have to solve for the sample size when you're given a specific margin of error. This is actually like the level 4 question on the chapter 8 test, and we did not go over the check your understanding that involved an example of this. We did talk about it in the big ideas, but we didn't actually work a problem out. So now is your opportunity to see one worked out. A small pilot study estimated that 44% of all American adults agree that parents should be given vouchers that are good for education at any public or private school of their choice. How large a random sample is required to obtain a margin of error of at most 0.03 with 99% confidence? Answer this question using the pilot study's result as the guessed value for p hat. Okay, so I think we need to remember that when we find a confidence interval, it's always the point estimate plus or minus the margin of error. If we break down the margin of error, we're reminded that it is the critical value times the standard error. And further breaking down, critical value is your Z star, and standard error, because this is just a one sample question, is this. You do not have to have the standard error formula memorized because it is on your formula sheet. Okay, so they're telling us that we want an error margin of error of at most 0.03. So I am wanting this to equal 0.03. I need to do some solving here. So let's find the Z star to go with 99% confidence. So 99% Z star. We are going to need to look at inverse normal, but I want us to think for a moment. If this is 99%, that means that this is 0.5%. And this is 0.5%. Okay, so when it asks me for area, I have to do area to the left, which is actually 99.5% or 0.995. So I'm going to go to the calculator and I'm going to go to inverse normal. And just in case I did that too quickly, you can do the probability or statistics. We need to get to distributions. And then it's right there. I put in 0.995 because that's the whole area to the left. Mean is 0, standard deviation is 1 because that's true for all z-scores. All right, 2.576. We usually do 3 decimals. That's kind of standard for z-stars. 2.576. Okay, so didn't mean to change the color, but that's fine. There's the z-star. They said to use the pilot study as our guessed value for p hat. So I'm going to plug in 0.44 as my p hat. Okay. And now it's time to do some algebra. Just a note that sometimes we don't have a guessed value for p hat. Sometimes we don't know a previous study or something, and so we don't actually know what our p hat should be because we haven't found it yet. So what we do is we just use 0.5. 0.5 is the conservative way to go. Let's go ahead and do a little bit of algebra. So to make my life easier, I'm going to go ahead and get rid of this 2.576 because it's on the outside of the square root, and I can go ahead and divide that. So 0.03 divided by 576, 0.0116. If I want to be most accurate, I would just leave that as a fraction. If you change it to a decimal, it's not the end of the world, but it'll actually be slightly more accurate if I just leave it. So I might do that. All right, so I have 0.03 over 2.576 equals, and I think I might go ahead and multiply these two just so that things are a little bit easier to write. Obviously, I could have just typed in 0.56 right here. All right, 0.2464. All right, so I'm in the purple one now. Again, I'm just doing algebra, which I love algebra. We just don't get to do it all that often. All right, I need to get rid of this square root sign because I'm trying to get the n alone. So I am going to square both of those. And because I'm just being extra mathy, but also kind of being lazy, I'm actually not going to do it because it's going to give me a decimal. That's going to be rounded. So now I have the 0.2464 over n, like isolated. Here's where people tend to make a mistake. The n is on the bottom. I can't just divide this to make it go away because then I have the n in the bottom. So technically, we're going to multiply by n on both sides to get the n to go away. And then we are going to divide everything by this so that we get the n by itself. So we move the n out of the denominator. And now we are getting rid of the fraction on the left side of the equation. I'm going to have n equals, and I just need to like type all of that in. So let's see if I can remember stuff. We have 0.2464 divided by, parentheses, 0.03 over 2.576, and that was squared. There you go. 1816.7. But I can't have 0.7 of a person. And if I round it down to 1816, that's my margin of error is going to be too big because like my sample size is not big enough. So we always round up. So we would do 1,817. Who are we talking about? Adults. Okay, let's see if we're getting the hang of it. And let's look at part B. Answer the question in part A again, but this time use the conservative guess, p hat equals 0.5. How much do the two sample sizes differ? So we're kind of going back up to here, and instead of using 0.44, we're using 0.5. 0.5 is more conservative. It's like if you don't know what your p hat is, 0.5 is going to give you the biggest sample size that you would possibly need for a margin of error this big. So I'm going to essentially copy this right here, except I'm going to put the 0.5 in it. I think I will do that in black over here. So I've got 0.03 equals 2.576 times the square root of 0.5, and 1 minus 0.5 just is 0.5. Okay, let's do algebra again. You could always pause this and see if you can do it on your own. I'm going to do like I did last time and actually not type this in the calculator. I'm just going to leave it as a fraction so that way it'll be, I don't have to round it. 0.5 times 0.5 is 0.25. Okay, so that went away. I multiplied those. Now I'm going to square both sides. You're welcome to jump ahead some steps if you don't feel like showing every single step out, as long as you actually do math correctly. But if it's safer for you to show all of your work to make sure you don't make a mistake, just show all of your work, please. All right, I'm going to multiply n on both sides because right now my n is trapped in a denominator. And now that it is over on the left side, I need to get rid of this other number. I wrote that kind of weird, sorry. I'm going to divide this on both sides. Okay. That means all that goes away, and I'm just left with an N, which is what I was looking for. Okay, let's see what that equals. Honestly, it's the same as this. I'm going to copy and paste it, but I'm going to change that to 0.25. Okay, 1843.2. So again, normally we would round down a 0.2, but we don't when we're talking about sample sizes. So we're going to round it up to 1844. I think it asked about like by how much do they differ, so I'm just going to subtract those two numbers. 27 people. So we have a difference of 27 adults. Note, I am putting units on all of these questions because it's like 844 what? We're talking about 844 adults.